Seshadri Ramkumar, Department of Environmental Toxicology, Advanced Materials Laboratory. Our work predominantly focuses on the material aspects to provide protection to humans from environmental toxins and other man-made toxins, and we primarily work on personal protective equipment such as face masks, aprons, medical gears, and so on and so forth. So we work towards countermeasures for chemical and biological toxins, and we also work on methods to protect oil spills and to absorb and adsorb toxic chemicals. So we are basically in the materials aspect of environmental research. We focus on advanced materials for chemical protection. So it's a very unique class where the students get some specialized expertise on how materials can be used to decontaminate and clean opioids and fentanyl. So those are all very unique skills the students from our department could gain, because not many programs in the country offer the material aspects and environmental aspects in conjunctions together. So we offer a specialized topic on countermeasures to chemical toxins. So one of the inventions from our lab, which is commercialized, is FiberTect, fiber that protects. This is one of the first set of patents filed from Texas Tech University and commercialized. So this technology helps to clean soldiers' skin, which has been contaminated with high-level toxic chemicals such as mustard gas. Washington, D.C.-based technology company has commercialized it, and I was told that many of government agencies and emergency units in the country are using, National Guards are using, and this is one of the success stories for Texas Tech. And Texas Tech has received royalty for a number of years for this technology. So this is basically lab to reality, a success. And most recently, the United States Army has put out a report showing that of all the commercial technologies available with regard to particulate cleaning, this wipe, FiberTect wipe, comes out to be the best. And also, another thing which thrills our lab is this technology is proven to work in sub-zero temperatures like Alaskan temperatures, where liquid-based cleaning technologies will freeze and they cannot be used, but our technology is a dry technology, so it functions well in sub-zero climates such as in the polar regions as well as Alaska. So this is a success story. This is lab to reality from our own lab at Texas Tech University. Assume that there is a spill, and this wipe, we can use it to clean. So that, and then the toxins will be absorbed by this wipe. So assuming that this is a human, actual human, so this wipe can be bent, can be squeezed, and all that can happen. So this is one of the inventions we have done, this wipe.
My name is Bumi Olopade. I'm studying environmental toxicology. I'm a PhD student here in the Advanced Materials Laboratory.
My name is Mirza Khayom. I'm a PhD student at the Department of Environmental Toxicology and working as a graduate research assistant in Advanced Materials Lab.
Currently, I'm working on wipes, decontamination wipes against fungi. So this material is made of cotton, and the good thing is that cotton is biodegradable and is friendly to the environment. So in place of the synthetic wipes we have around, we are using cotton materials to make antifungal wipes and then functionalizing them with essential oils, which are also antimicrobial, to help clean surfaces. And this project is useful in hospital environments, in food industries, in restaurants, in offices, in various parts of the world.
So this is the fractional efficiency filter tester. We usually test the filter efficiency using that machine, and this machine can generate the particle size ranges from 30 nanometer to 400 nanometer, and that particle we apply onto the filter substrate, and it can give us the result how efficient that filter and how efficient that filter can filter that particle size at that efficiency. And this machine we use for the plasma treatment on the surface of the materials. That treatment actually cleans the surface of the material, and it activates the chemical, functionalize the surface of the material, which is helpful in the filter industry and also in the personal protective equipment study sector.
Our lab works on developing materials using sustainable technologies and processes such as plasma technology. So we will generate plasma, which is nothing but ionic form of gas, and then see we are using a surgical drape or surgical gown, and then we are bombarding with ionic plasma there, so that will functionalize the surface, so the medical gowns can be made antiviral or antibacterial. At the same time, they can repel bodily fluids such as blood. So we are able to provide materials that will enhance human health and at the same time protect the environment, because we are using waterless technologies. So there are so many success stories. Many of my former students are well employed in multinational companies, and they are in the director for research and innovation positions. And my current students are doing extremely well. One of my students is Mirza Kyum. He has been receiving all sorts of awards from Texas Tech University, and he won twice Best Student Award in the department. And he is in a verge of filing his second patent, and his work focuses on face masks and using advanced technologies such as ionic plasmas to provide new materials that can clean up toxins. So there's so many success stories, and I'm very thrilled to have such high caliber students in our lab.